Hello, and welcome to From Stress to Decompressed, where we try to learn about various compression and decompression algorithms, and we implement them in order to get more familiar with them. And this will be hosted in a GitHub repo, the materials for this, and that will be in this link, which I will post in the description as well. We are going to be using a language called Odin for this tutorial, which I will also post the link in the description as well. Okay. And we will take a look at the intro section, where we will implement a form of compression known as RLE, and we're going to be doing a custom format for it just so I can keep things simple. It is used practically in the field as well, but mostly not really used that much, but we're going to do a custom one, so whatever. And what RLE even stands for in the first place is run length encoding. And so you have various runs of bytes, as you can see here, and we have like some sort of byte to indicate that it is a run length, and we have the length here, and then we have the byte that's actually used for the run. So we have just repeats of 4, and we can describe that as 4 bytes of 4. I made this 3 because we need at least 1 byte anyways, so we might as well just like save, we might as well describe the length -1 in order to expand the range a little bit. We can do 1 to 256 instead of 0 to 255. It also makes the decoder a little bit simpler. So I'm going to go to reference, and we have a couple. Let me clean that up a little bit first. Yep, and I'm gonna say make. Yeah, we have a make file here, and this makes our reference. Okay, so what does the reference do? Okay, so I just need to provide it an input and output. Sure, let's be a little bit meta. We can say I want to read myself, and I want to make that compressed. And you can see there's like a little bit of a result here. It's not too much. You could definitely get away with more if you used a more complicated algorithm, but that's not bad, right? Not bad for the simple algorithm I'm about to show you. Okay, and that's cool. So we have a reference encoder right there, and I'm gonna say, okay, let's make a decoder now. So we go there because I'm lazy. I'm going to actually copy everything in the reference to here. I'm going to name this actually decoder instead. I'm going to make clean. We have a clean target as well. And we're going to take a look at the decoder. Okay, so this program is also going to be really simple. It's just going to take an input and output. We have the input name and the output name right here. Because I'm being lazy, we're going to read the entire file into the input buffer. Because I'm also being lazy, we're just going to keep appending bytes in the output buffer, and then we write the entire file. So that's cool. Okay. So now let's implement the decoder for this algorithm. I'm going to remove that, and I'm going to declare I. And I'm going to say the run length equals 1, and then the byte that we want to use is in buff I and I'm going to say if b is equivalent to run byte, then, which is right here, so we use this to indicate that there is a run in the first place. Then, what was it that I wanted to do again? Right, if I plus 2 is greater than or equal to len in buff, then I want to print out a certain message. Yeah. And that message will be that, so we can sort of tolerate this, so we'll just break here instead of like exiting like we do in other places. We'll say warning that the run is truncated, not doing anything. Remove this. Okay, we're gonna break. And then I say, right, instead run length equals in buff I plus 2. D equals in, well actually it's I plus 1 if I remember correctly. Yeah. I plus 2. And then I plus equals 2 in order to skip over these 2 bytes. And then 4j in 0 dot dot less than run length. Oh, we also want to add 1 here. Forgot about that. Okay. Then I'm going to say append our buff the byte, and that should be it. Yes, and we can just test that out right now. And then let me see the reference. Did I have that built already? Yes, I did. So I can say reference. I'm going to put that in the decoder. And then, so I'm going to use reference exe. And again, I'm going to do the same trick where I try to make it compress itself. Okay, and that's great. Now let's use the decoder. It's the same instruction, so I'm going to get the reference that's compressed, and I'm going to make a copy of it. And you can see that these are the same number of bytes, so that's promising. And then I'm going to diff these files just to check that it was in fact preserved, because that's exactly what we want. Not compressed, just exe. Okay, and yep, everybody's preserved. The diff passed, and so that's a working decoder. In addition to the decoder, we would make an encoder, because the reference is A, something I'm going to give you, and B, it's going to be using an external library. And so we're trying to learn this comprehensively, so having an external library removes the point. And so we're going to make a separate encoder as well. Because we didn't use external libraries in our reference, actually, we can take a look at it right here. I'm going to move the file first. Yes, like we're not using external libraries here, we're doing this manually. So copying and pasting is fine in this situation. And you can sort of take a look at the reference code if you want to know how to do that. It's really simple, so you can do it on your own, but if you want a shortcut, that's there. So I can make the file again, right, and the encoder works the same way. I'm not going to bother testing it because it's literally the same thing, but that's there. And that's about it. We're done. Thank you all for watching. I hope you all have a good day today.